This is a kind of continuation of a video I was doing before. Summarizing all the tools that you need to be able to simplify an expression in Math 140 or college algebra. So the one thing we haven't talked about is dealing with fractions, although we've mentioned them a little bit when we're dealing with powers, but just want to hit this a little bit harder. There's basically, what do I got here? 1, 2, 3, 4, 5, 6 things you need to keep in mind about fractions when you're multiplying them. And then, of course, in the process of multiplying, we often cancel. And division is very closely related to multiplying. And then we need to be able to add and subtract fractions, and we can do that by getting a common denominator. And finally, we need to be able to handle some complex fractions. So let's start up here at the top, multiplying fractions. So when you're multiplying fractions, you multiply the top by the top and the bottom by the bottom. But you can also, of course, cancel things. So if I have, for example, 3 over 4 times, 9 over 4 times 5 over 7 times 8 over 3. Okay, this looks like we have 3 separate multiplication things, but the cool thing about fractions is that this turns into one just big fraction where you have 9 times 5 times 8 and 4 times 7 times 3. And then in reference to what we've said before, really this is just the commutative property of multiplication kind of kicks in here, because I can multiply and divide in any order I want as long as I pay attention to what's on top and what's on the bottom. So in this case, technically I should, if I followed order of operations, I should multiply 9 times 5 times 8 first and 4 times 7 times 3 first and then do the division bar. But if I notice that there's a factor of 4 in the top and the bottom, I can go ahead and cancel before I multiply. So I can cancel that out. Let me use a different color, sorry. I can cancel that out and cancel that out, leaving a 2 up here. I can cancel the 9 and the 3, leaving a 3. And I think that takes care of everything. So that gives me, and again, I can still multiply in any order I want. So I can multiply 2 times 5 is 10, times 3 is 30. And there's nothing down here left but a 7. So we get 7. Okay. So that's both multiplying and canceling. So you want to keep just that general idea in mind, that you can you multiply the top by the top and the bottom by the bottom, and it doesn't matter how many strings of multiplying, of how many strings of fractions multiplied together we have. Still, everything on top is multiplied together, everything on the bottom is multiplied together. However, you can cancel any like factors on the top and bottom. So notice here, the reason why we can cancel this 9 and 3 is because really 9 is 3 times 3 and 8 is 2 times 4. So what we're doing is really canceling out that 3 with that 3 and that 4 with that 4. Okay? So, and of course, this gets a little bit more complicated when we have variables, but we've done some of those already. So if I had 3x squared over y cubed times 4x squared over z to the second times 5z to the fifth over 9. Okay, once again, you don't necessarily have to do this first, but what you're thinking is that all of the stuff on top is just multiplying together. And everything on the bottom is multiplied together. And so then I can begin looking for things to cancel. For example, I could cancel 2 of these z's with 2 of those z's. So let me change colors again so it doesn't all blend in together. So I can cancel 2 of those z's with, because this could be broken into z to the third times z squared. So that z squared we canceled out. And this 9 could be broken into 3 times 3. So I can cancel this 3 with one of those 3's. And I think that's all the canceling I can do. So then I'll multiply on top what I can multiply. So I have a 4 and a 5. So 4 times 5 is 20, of course. And there's an x squared there and a z cubed on top. And on the bottom, it looks like I just have a 3y cubed. Looking fun. But now keep in mind also that now that we have we know how to factor, we can handle something like this, like x squared minus 9 over x squared plus, let's see, plus 6 times, let's say, x plus 2 over 5x plus 15. Okay, so here it's the same idea. We're multiplying everything together, but just like these, I think we left these in kind of factored form, or we put them into factored form. It's a good idea to put these polynomials into factored form also. Just making a little room here. So if I was to multiply these out, I would put them in factored form first. So that would be x minus 3 times x plus 3 times x plus 2. Notice I'm bringing in the parentheses because I'm multiplying. When I'm multiplying, I really mean this whole thing times that whole thing. So I can't just multiply this times the x. It's multiplying by the x plus 2. Now on the bottom, I can factor that into x plus 3 times x plus 2. And I can factor out a 5 there. That'd leave me with x plus 3. Okay, so now when we before we multiply things out, we look for things to cancel. And I notice that I can cancel that with that. Oh, whoops, shoot, I wanted to change the color again. Okay, so I can cancel the x plus 3 with the x plus 3, and the x plus 2 with the x plus 2. And that's all I can cancel. So then when I multiply this out, I get x minus 3 over 5 times x plus 3. And of course, if I want to write that in simplest form, I would write it as x minus 3 over 5x plus 15. Okay? So that's the idea of canceling when we have multiple terms in there. So notice up here, we didn't have multiple terms. It was just a bunch of things multiplied together. Remember, terms are separated by plus or minus sign. Here we have terms, so you cannot cancel just with the 9 with the 6 because they're not factors at the top and bottom. You have to find factors. So you have to take something that's written as a series of terms added together, and you have to turn them into factors. So see how we have factors on top and bottom. So notice this, the top is x minus 3 quantity times x plus 3 quantity times x plus 2. So each one of these things is a factor at the top. Just like down here, we have 4 factors. We have x plus 3, x plus 2, 5, and x plus 3. Okay? So, now also remember that, as I've said before, x plus 2 can cancel out as long as x isn't negative 2. Because if x is negative 2, this would really be undefined. So when we're canceling things out, we have to keep in mind that that means that x cannot be equal to negative 3 or negative 2. Because if it was, we wouldn't be able to cancel these out. So if you're asked to simplify a fraction like this, and they ask you what can x not be equal to, which they'll do that in the XYZ homework sum, you're just paying attention to the things that you canceled out, and you're asking what makes that factor 0. So in other words, I would replace x with -2 to make this factor 0, and I would replace x with -3 to make this factor 0. And those are the two factors that I canceled out. Okay. And this, of course, the same idea applies to division. If I have, for example, x squared minus 4 over x squared plus 4x plus 4 divided by x minus 3 divided by x plus 2. Okay, first thing I would do in this case, because I apply this idea that division is multiplied by the reciprocal. So as I'm flipping them and stuff, I'd factor them first. So x squared minus 4 would be x minus 2 times x plus 2. And on the bottom, I'm going to have x plus 2 times x plus 2. And then this is going to have x plus 2 on top and x minus 3 on the bottom. And once I flip them, then I'm just multiplying. So make sure we put parentheses around that. And I'm going to grab a different color. So then I begin looking for things to cancel out. So there's an x plus 2 and x plus 2, x plus 2, x plus 2. And it looks like I'm left with an x minus 2 over x minus 3. And once again, if I was asked which x's don't work, x cannot be equal to -2 in this case, because that's the factor, that's the 0 of the factor that we canceled out. Okay, so let's do a couple more here. So then the next term is, or the next concept that we have to understand, so let's see, we got that now. To add and subtract, we must have a common denominator. So if you remember this, when we had like 2/3 plus 3/4, we can't add those together because this would really even fall under the like terms. Because remember, in a fraction, the bottom number is telling me how to divide up a whole, and the top is just a counter. So this is saying 2/3 means I have two 1/3 pieces of something, and 3/4 means I have three 1/4, or three 1/4 pieces of something. So again, the bottom number is telling me how to divide up a whole. The top number is counting how many of those pieces. So in order to add them, I can't really add them unless they're the same pieces. So that's why we have to get a common denominator. And so we say, we look for something that both 3 and 4 will go into, like for example 12. So we're going to rewrite this as something over 12 plus something over 12. And the way we change the denominator is the same way or the reverse way of how we reduce fractions. So we know when I have, for example, 30 over 6, we can reduce that because it's 5 times 6 over 6, right? And the 6 cancel out. Well, the same idea is here. I'm saying, what can I multiply 3 by to get 12? That'd be 4. So that means I'm just going to multiply top and bottom by 4. So that would give me 8 there. And since I multiplied top and bottom by 4, it didn't change the fraction at all. It just makes it look different. Same thing here. What did I multiply 4 by to get 12? That'd be 3. So I'm going to multiply top and bottom by 3. So that would be 9. So then we add them together, and we get 8 plus 9 is 17 over 12. And that's adding fractions. Of course, this same idea applies when we're dealing with variables. So if I have 1 over y plus 2 over x, I want to add those together, I have to get a common denominator first, which in this case would be yx. So same thing I did up there. In order to get this to be yx as the denominator, I have to multiply top and bottom by x. So this is going to have the x up here. And to get that to have the right denominator, I have to multiply top and bottom by y. So that would give me 2y right there. And then when I add them together, I get x plus 2y divided by yx. So once again, this is like terms where they only have fractions are considered like terms if they have the same denominator. If they don't have the same denominator, we can't add them together. But the nice thing about fractions is we can usually make them have the same denominator. Okay? So that's a quick reminder about adding and subtracting. Of course, subtracting is the same way. We just subtract them instead of adding them. All right, the final topic is simplifying a complex fraction by multiplying top and bottom by a common denominator. So if I have, for example, 1 over x minus 3 over 1 over y plus 5. So this is considered a complex fraction because it has a fraction within a fraction. So if I want to simplify this, what I would do is first move I want to do is get the fractions out of the fractions. And so the best way to do that is to multiply top and bottom of the fraction by a common denominator once again, just like I did with the adding. So the common denominator of all the fractions within the fraction, so I'm looking at 1 over x and 1 over y, the common denominator would be xy. So I'm going to multiply the top by xy and the bottom by xy. When I do that, xy times this, so of course I have to distribute, right, because these are really grouped together. Xy times 1 over x would be just y, and xy times negative 3 would be negative 3xy. Same thing down here, xy times 1 over y would be just x, and xy times 5 would be positive 5xy. And you can see that we greatly simplified this because there's no fractions within fractions now. And then, of course, at this point, we might check to see if there's anything that can be factored out. I can factor out, I can factor out a y here, and that would leave me with 1 minus 3x. And I can factor out an x here. That would leave me with 1 plus 5y. But notice that doesn't do anything for me. It doesn't provide any things to cancel. So once I discover that that doesn't help me, I'd erase that and leave this as my final answer, because factoring, remember, is the opposite of simplifying. Okay. So there's the rundown of the different concepts that are important to know for handling fractions. And I will be posting a worksheet real soon with a lot of practice for this type of stuff. So look forward to that. But you should be able to work your way through the exercise homework now.